All right, so in this enrichment, we worked some problems in class with a friend, and now I'm going to go over them. So if you're watching this video online, what I recommend doing is pausing the video, working these problems for yourself, and then when you're ready to see the answers, you can resume the video. So there were 5 problems, each of which I asked you to give the molecular, complete ionic, and net ionic equations. So now let's go over these. All right. So you'll need your solubility rules handy if you don't have them committed to memory, which you probably will after you do this enough times. All right, so the first problem says it's iron 3 chloride solution plus barium nitrate. Now these are both solutions. So do I need to look up to see if these are soluble? No, the problem tells me they're solutions. So therefore I know that they're soluble, right? So this molecular, that will be FeCl3aq plus barium nitrate would be BaNO3 2aq. And I need to adjust my camera here. I'm going to run out of room. There we go. That'll give me some more space. And so this is a double displacement reaction, right? So I'll get iron 3 nitrate. So that would be FeNO3 3. Is that soluble or is that insoluble? Look at your rules. That would be what? All nitrates are soluble. So what subscript does it get? AQ plus barium, what? What's barium getting together with? BaCl2, right? What's this one? Looking at your chlorides. All chlorides are soluble except Ag plus, Hg2, 2 plus, Pb2 plus. So what's that one? That one's soluble as well, so it gets AQ. All right, now we just need to balance this. All right, I need a 2 here, and a 3 here, and a 3 here, and a 2 here. Okay, so both my products are soluble. What do I do from here? Do I need to write a complete ionic? Is it even possible to write a net ionic? No, what do? I stop and I say what? No apparent reaction, right? This is no apparent reaction, right? You can just write NAR, right? And why? Because both products are soluble. Right? If you go through and you dissociate every single one of these, it's all going to cancel out, right? Iron 3 nitrate, soluble. BaCl2, soluble. So everything's going to cancel out. Everything's going to be effective. So I mixed 2 solutions and nothing happened, right? There's no apparent reaction occurring here. Do we agree on number 1? No apparent reaction. All right, let's do number 2. Number 2 says, this is iron 3 chloride again, solution, plus lithium hydroxide solution. So this would be FeCl3, just like it was a minute ago, aqueous. And this is LiOH So this is the molecular, by the way. And so this is double displacement, right? So we're going to get FeOH what? How many OHs are there? 3. Is that aqueous or is that a precipitate? That one's a precipitate. What state does it get? S. Plus LiCl. What about that? What state of matter would that one be? Is it solid or is it aqueous? That one's aqueous, right? Okay, now we just need to balance. Let's see, we need a 3 here and a 3 there. Right? 3, 3, 3. Yes. Okay, now let's do the complete ionic. Because there is a precipitate, we have a complete ionic to write. Right? So for the complete ionic, we're going to take everything that's aqueous and we're going to dissociate it. Right? So this becomes Fe3 plus Aq plus 3Cl minus Aq plus 3Li plus Aq plus 3OH minus Aq. A lot of times when I see students have a coefficient out front, they'll give it to the first, the cation, and they'll forget to give it to the anion. That's a really, really, really common mistake I see. Then what do I do with my precipitate? Leave it alone, don't touch. FeOH3S plus 3Li plus Aq plus 3Cl minus Aq. All right, complete ionic is redundant though, isn't it? Because if there are substances that start out and end the exact same way, then they didn't really do anything. So what are my spectators that I can cross out? What are they? Li plus is one of them. Notice my coefficients match. And what's my other spectator? Which one? The Cl minus, right? So my net ionic that I'm left with will be Fe3 plus Aq plus 3OH minus Aq produces FeOH3 solid. Don't forget, when you're doing your complete ionic, do you need the charges? Absolutely have to have them, right? Because is Fe the same thing as Fe3 plus? No, iron metal is definitely not the same thing as the iron 3 ion, okay? So I will take points off if you don't put those charges. Is it necessary to have those subscripts? Yes, I will take points off if you don't, right? Because that's telling me that it's dissolved in water. This is telling me that it's floating, that it's sunk to the bottom of my beaker as a precipitate. Okay. Is everybody good on number 2? Number 2. All right, let's take a crack at number 3. Number 3 is iron 3 chloride again. Getting lazy, huh? Iron 3 chloride. Does anyone remember what that color of the solution would be? We've worked with it this semester. Maybe not iron 3 chloride, but we've used iron. You remember what color it is? Orangey, reddish, depending on the concentration. And cobalt 2 chloride. Ooh, cobalt 2 is really pretty too. These are both solutions, so do I need to look up their solubility? I mean, before I even start, before I even go through this, I already know that this is no apparent reaction. Why? They're both chlorides, right? I mean, before I even write the molecular equation, I go, okay, when this double displacement occurs, iron 3 chloride, iron 3 gets together with chloride. Hey, it's iron 3 chloride. Cobalt 2 gets together with chloride. Hey, it's the exact same, right? I mean, here, you can say this is no apparent reaction before you even write a molecular equation because both are chlorides. Products are the same as the reactants. Right? If they're both chlorides, you're going to start out with iron 3 chloride and barium cobalt 2 chloride, and you're going to end up with iron 3 chloride and cobalt 2 chloride. Right? There's literally no change here. Both of them are chlorides, so that's no apparent reaction. That saves us a lot of writing. Woohoo! So if you've got the same anion, then that's like what you want, right? Because that's less work for everybody. Does everybody see why this is no apparent reaction? Okay. Let's do number 4. This is ammonium sulfate. Finally shook stuff up a little bit. Ammonium sulfate. And it's combined with a silver 1 nitrate. Now, I told you in the problem that these are both solutions, so I don't need to look up their solubilities. If I did, they'd both be soluble, though. Ammonium sulfate is soluble. So that's NH4 2 SO4 AQ. That's a 4. Plus AgNO3 AQ. When I do my double displacement, what am I going to get? What will the silver compound be? Ag, what? 2 SO4. Is that soluble or insoluble? That one's insoluble, right? So it has the S. S does not stand for soluble, right? S stands for solid. If you look at your solubility chart, salts of sulfate are all soluble except Ag+. And my other product will be what? NH4 ammonium nitrate, right? Is that soluble or insoluble? That one's soluble. That one's AQ. Okay, now I just need to balance. I need a 2 and a 2. All right, so that's the molecular. So now let's do the complete ionic. Some books call it total ionic, by the way. If you ever see a book or you're reading something that calls it a total ionic, that's the same thing. Okay, so don't let that throw you off. So 2 NH4 plus AQ plus SO4 2 minus AQ plus 2 Ag plus AQ plus 2 NO3 minus AQ produces Ag2SO4 solid, right? We leave the precipitate alone, plus 2 NH4 plus AQ plus 2 NO3 minus AQ. A lot of writing, I know. In the complete ionic, I have spectators, right? And the net ionic, I don't have spectators. So which spectators can I remove? Which are the spectators? There are 2. Which ones? Ammonium is one. And what's the other one? Nitrate, right. So what I'm left with is the net ionic. So it doesn't matter which one you write first, 1 plus 3 or 3 plus 1, right? So long as when you write the compound, it's in the correct order. That's all I care about. Right? If you put sulfate first in the salt, that would be bad. That would be incorrect, right? But if you put it first here as you're combining them, that doesn't make a difference. Okay? Do we agree on this one, number 4? Any questions on 4? All right, last one, number 5. Okay. Number 5 is silver 1 nitrate. Again. And sodium phosphate. Both of these are solutions, right? So I don't need to look up their solubilities, but if I did, these would both be soluble. So this is for my molecular. AgNO3, AQ plus Na3PO4, AQ, produces, what's the silver compound going to be? Ag3PO4, right? Aqueous or soluble? Aqueous or solid? That one's solid, that's a precipitate. If you look at your solubility rules, phosphates, the only soluble phosphates are ammonium and group 1. And NaNO3, go ahead and balance. That one's AQ, right? And we need a 3 here as well. Do we agree? Sure.
How do you know that the other one, the PO4, the nitrate? Yeah, sodium.
How did I know that was soluble?
Yeah.
Well, the problem tells me it's a solution.
Okay.
But if you look at your solubility rules for phosphate, it says all of them are insoluble except ammonium and alkali metal. Alkali metal is group 1, and sodium's in group 1. Does that make sense?
Yeah.
Okay. All right, now we can dissociate. Because we have a precipitate, we can continue. Okay, so complete ionic. That'll be 3Ag plus AQ plus 3NO3 minus AQ plus 3 Na plus AQ plus PO4 3 minus AQ produces my precipitate Ag3PO4 plus 3Na plus 3NO3 minus. Got it writing. But I've got spectators in here that I need to remove to give me a complete ion, to give me a net ionic. What spectators can I remove? Nitrate and sodium ion. Right, remember, we can use this as a self-check to make sure that my coefficients match before I cross them out, right? If you had 2 on one side and 1 on the other, that should ring a bell to go back and double check here, right? How you dissociated. So what you're left with is the net ionic. So 3Ag plus AQ plus PO4 3 minus AQ produces Ag3PO4 solid. So your quiz on Monday will be on this, okay? That's what your quiz on Monday will be about. Monday we'll talk about concentration, and we'll also talk about dilution on Monday. Any questions on these, though? Feeling pretty good? All right, that's where we'll stop.